Ladies and gentlemen, it's just after 8 o'clock. We're going to get started. I'd like to welcome everybody to the Wrama March meeting today. We've got a very full agenda today. We've got lots of 4 speakers tonight. Can I ask everybody, we'll start off with some administration stuff. Could you please turn off your cell phones or put your phasers on stun? That would be greatly appreciated. We are recording our presentations tonight, so it's just to avoid any embarrassing phone rings while people are presenting. That would be greatly appreciated. So, Steve, are you ready? Okay, without further ado, let's give a warm Wrama welcome to Stephen McDonald. Thank you, Bill. I'm going to hang out up here. Hopefully, my trusted assistant will flip the slides as we go through. We'll give you a little fat signal.
Yeah, it's a nice group. I could try. Can everybody hear me okay? I know there's some other people coming in. We can wait a minute. Louder, louder, louder.
Yeah, here's the mic.
We gotta use the mic. So I'm the general manager of Afterglow. We've been in business for this will be our 23rd year. The founder, George, my dad, sitting over there. So nice to have you here, Ted. And appreciate everything you've done to help grow the business, or grow the business. I'm helping it. If we could just go back a bit. So we know the industry generally as an HVAC industry. It includes boilers, furnaces, HRVs, that type of thing. So we know it as a heating, but a lot of times we refer to it as a heating and air conditioning. But one back. There we go. The acronym of that is a HACK. Now hacks generally nobody likes a hack. You can't skip the V in HVAC. It's a very, very important component. And a lot of times it gets missed. So if you say you're a heating and cooling company, you're more than that. We have to do ventilation. I'll just touch on ventilation. People have seen, go ahead. People have seen and smelled problems in homes, odors, air contaminants, humidity, high humidity or low humidity. Ventilation is a very critical component for homes, units, apartments, etc. So if you can take one thing from this, keep in mind that beyond heating and cooling, ventilation is a very big component for the healthy home, and it'll be emerging. It's emerging as a very important issue. So that's all I'm going to say about ventilation, although as I started it, but the other stuff will be touching on some tips. So the topics for tonight, the code says thou shalt. We're going to look at some service tips for boilers, water heaters, and furnaces, and then trends for boilers, water heaters, and furnaces. So go ahead. This is what the code states. Now it's a lot of words. An owner or user of an appliance, equipment or work, or anything employed in the handling or use of gas, so that means any gas appliance, shall ensure that the appliance, equipment, work, or thing in the handling or use of gas is maintained in a safe operating condition. That's what the code, that's what our regulation, Ontario regulation says. So how does the inspector, can go again. The inspector wants, now this is what he wants, and he'll only want it if there's an incident, and the last thing we want to have is an incident. And I say it's like this, you could drive your car every day, you never get pulled over, but if you're in an accident and you don't provide your documentation that you're a certified driver, licensed driver, you're in deep trouble. So if there's an incident, and we do get them, I don't know how many happened this winter across Ontario, but probably more than we care for. With proof of service, maintenance, from a registered certified company. That's what the inspector is going to want to see. And he's going to want to see annual inspections. I talked with the inspector, that's exactly what they want to see. And then generally speaking, they're looking to get rid of chimney vented boilers. So a lot of older buildings. I have customers here that have chimney vented boilers. Nobody, the inspectors, the regulatory bodies don't want chimney vented boilers anymore. So they want what we call a direct vent boiler, which is sealed combustion. Air comes from outside to supply and gets exhausted directly outside, either through a plastic pipe in a chimney or directly out through the sidewall. So that's generally what the inspector will. And with regard to codes, we have some pretty significant codes, but really it's affecting residential new construction. So, you know, if we're in a rental market, unless we're building new, now we do see some new stuff getting built. There's one by my house on Waterloo Street, new construction. You can have programmable thermostats. That's of January 1st, 2014. That's a code now. We want duct sealing for all air ducts. That's code. For new construction, ECM fans, which are the high efficiency fan motors in furnaces, January 1st, 2015. So these are pretty significant in our industry. We don't see it a lot in retrofit. If you have existing buildings that are older, that doesn't play a big role except for some of the rebates. But it will be mandatory in January 1st, 2015. And then also what's changing, and this doesn't really affect the end user, but the CSA F280, which is a big document on how to size equipment, so determining what size furnace you need or what size air conditioner you need, those rules are changing next year. So those are significant numbers and code changes for us. But again, it's really a new construction. Certain segments of the industry see that. Also, carbon monoxide detector. We may have heard that Ontario passed regulation to make sure that houses and units have carbon monoxide detectors. It is effective, but they haven't decided which date that's going to come into effect. We'll go ahead. So the tips, which is, go ahead. So tips, these are things that as an owner you can do, and I'm just going to list them here. You inspect for leaks. Some may recognize that boiler, it's a nice boiler. Open the door of the boiler and have a peek inside. No, you can do that, you don't need a license to do that. Check the venting for stains, rust, or perforations. You want to check the pressure gauge of the boiler and even look to see how the expansion tank is doing. Inspect pumps and inspect the relief valve. Like I would say every 1 out of 10 boilers I visit has a leaking relief valve with a bucket underneath. People say, whoa, not sure why that's happening. Or they have a hose going from the relief valve to the drain. It's really a symptom of something else that's happening, but it's crying for service is what it means. Go ahead. So also, this is a heat exchanger that has not been looked at for many years. Not that many years. Some people will go 20 years without looking at a boiler. This heat exchanger is probably 4 or 5 years old. Some serious contamination in the burner, so the burner would fit right into that space. So this is why, especially on high efficiency equipment, it needs to be opened up and inspected every year. So this is not we didn't throw a bunch of mud in that boiler, that's exactly how we found it. Perform the combustion analysis. So this is giving, you do a test with a pretty fancy machine to see how the boilers function, where the carbon dioxide levels are, etc. I have a slide on that. Check for carbon monoxide. Gas pressure.
What would be the cost of getting in there?
It could be some dirty combustion, so there could be some air blockage, some of the gas, or it'll propel itself, self-propel into that state. If there's dirt on it, there's maybe a water flow issue.
People don't change their filters regularly?
That's on the combustion side, so it's not a filter. But also for maintenance, consider replacing the pilot assembly or igniter we have clients that do it every other year. We'll go and visit their boilers, inspect them every other year, replace the pilot. So that's the weakest thing. While we're there, it's very cheap to do it at the same time. So we might recommend as a pretty cost-effective tip to make sure that the equipment stays running. Go ahead. So this is an example of a combustion analysis. This would get printed off from our machine and taped to the boiler. Go ahead. So we saw this a lot this year. So that's the left photo is that's an air intake actually that's located beside an air exhaust or a vent exhaust on the side of a house, and it's completely frosted up. every contractor, maybe even some people had that problem. Now this would be again with high efficiency equipment. Every contractor in Canada had those problems, or dealt with those problems this year. So that's a frosted up air intake. The appliances starve for fresh air, and it would stop running. So we get a service call. Now it's not ideal, so certain things would have to get changed up. The other one is a condensate hose that is kinked. So sometimes that happens. So condensate, all high efficiency equipment is making condensate, so it's making its own water that has to go to drain. So here's a very simple problem. It's a kinked hose. So as a building owner or homeowner, you can just do some of those visual inspections, check the vent, check that condensate hose. If it's kinked, maybe unkink it and it might just work. Go ahead. So venting, and we see, this is essentially why, if you see that photo, there's perforations in that vent. This is rusting and spilling flue gas out into the home. So if you see this, you might see this in an old boiler room. We see it in boiler rooms in commercial buildings, multi-residential, see it in homes. This we discovered 2 weeks ago. This has to get replaced. This is, especially as a building owner, it's a liability waiting to happen if a tenant realizes that there's a leak, or whether really they've been suffering. They may be suffering from some symptoms of carbon monoxide. That has to get fixed. So another tip, install carbon dioxide detectors, carbon monoxide detectors. And make sure, so if you just check your vent and get your annual inspections done. That's it for boilers and just some service tips. These water heaters, this is a very standard water heater. It's been around for a long time. Really does nothing for you efficiency-wise. There are some minor maintenance things that you can do to replace the anode rod, flush it from fourth line on the water side, make sure its burner is clean. Very common type of water heater. Again, I would say it's going to go the way of atmospheric boilers. It's going to go, this will become obsolete. Won't be in 10 years, but probably in 20 years, this standard water heater will be gone. Go ahead. So yeah, this is an example of a flushing of a direct fired water heater, the line that comes out. Go ahead. So furnaces. I would say a lot of the same things apply to furnaces as they do to boilers, in that you could look at the venting, make sure the venting is okay, condensate. The main difference is you won't see these, you might see these in multi-unit, multi-residential apartment buildings, but a lot of times they'll be serviced by a boiler or a main system. So this you might see in your townhouse or rental house. Again, combustion analysis, carbon monoxide test, gas, test the gas pressure. Go ahead. But just one tip I want to leave with it, and we see this all the time in rental homes with furnaces, the filters are dirty. So whether you buy a box of filters, if you have these type of units, and leave them in the basement and ask, even set it up as an email reminder that you remind the tenants to replace the filter every couple months. And not get this fiberglass style. You want a pleated, so this one on the right is a pleated filter. It costs a little bit more, but it's much better for airflow, and it's a much better filter. So when that one gets clogged, it becomes a mat on top of it, all the dust, etc. There's no airflow going through the furnace. The furnace will go off on a limit, where this one can tolerate more dirt getting built up, and it'll allow more airflow. So you want a superior filter, costs a little bit more, but your furnace will thank you for it. Go ahead. So some quick trends for boilers and some other HVAC stuff. Go ahead. So boilers, really we haven't installed what we call a mid-efficiency or chimney vented boiler, I would say now in 6 years. Everything is high efficiency, kind of like the furnaces. Furnaces were mandated to be high efficiency, but boilers, virtually all boilers are high efficiency that we install, and you want them modulating so it'll gear the amount of heat that it's putting out based on the heat loss in the building. And you're also able to do more diverse stuff like do domestic hot water, snow melt on ramps, or pool heat. Go ahead. So essentially our goal is to match the building heat loss. And so the newer style, modulating, which means that the gas burner can go down from say 10% up to 100% fire rate. It can match the heat loss of this building, whether it's at 0 Celsius, minus 10 Celsius, minus 20 Celsius. You want to kind of match that heat loss. Go ahead. And so some of the other trends are in the radiators. On the left-hand side, you'll see a lot of the buildings that were built in the 60s and 70s have these high-temp fin tube radiators. They're on the left. They'll have to run at a very hot temperature to get any heat out of it. So you'll see that there are some migration to this medium temperature panel radiator. So they're more of a European-looking radiator. Superior, they can put more heat out at a lower temperature. So that's a way to get your efficiency up and reduce costs. This other one would be in a new construction, high mass, concrete floor, so in-floor heating. You see that in some new buildings that get built. Go ahead. Trends also in pumps. So the pump hasn't really changed that much over the years, except I would say in the last couple of years, the emergence of the high efficiency pump. So it's using the same kind of ECM technology that the fan motors do. They're stating that it's going to be 70% more efficient going to a high efficiency pump. In this case, it's a twin pump, so if one goes down, you'll have another one to back it up. And there's a couple different ways it can work. We were, fortunately, the first one in Canada. It's a Grundfos. It's a pretty big pump. Put it in a multi-res apartment. And Afterglow was the first company to install one in Canada. It's a I'd say that pump, although it costs the price of a small car, is very fancy. But it's also serving like 70 or 80 unit apartment. Go ahead.
We were just playing with that one today in the lab.
Oh, is that very one?
Not the twin, but the single version.
Yeah.
They're not so expensive compared to like the gum version of it. $1,000.
That one?
The single version of it.
Oh,
With
yeah.
the Grundfos with the programming.
This one was a little bit more, but it was a bigger one. It was a
Yeah, it's a big one.
But they're very nice.
Cool.
And you can hook up your iPad to it.
Yeah.
You can communicate with it and find out what it's doing. So, everything has to get hooked up to an iPad.
Yeah.
So now you're pumped. So we can go there with our the iPad, download its history, see what it's doing, if there's any faults, etc. So we have a little conversation. Go ahead. So this, the other trend is for domestic hot water in bigger buildings is getting off the old style vented water heater to an indirect. So that coil in there will use boiler water to heat water. So it's a hot water heating water technology. Very superior. Now this has been around. We have customers that have these systems in for 25, 30 years. Probably, they're some of the original Beastman customers, and the stuff is still working. This is a very efficient way of heating hot water, and you're getting away from multiple vents or using the chimney for water heater. So we've been putting these in for 10 years or more. Again, they've been around for, I would say, 25 years. Go ahead. This is interesting. Now we have a residential size condensing high efficiency domestic hot water. So this is something people have been, and it really is driven by new construction. You can get a high efficiency water heater. It might be operating about 90%. So this is good for suburban homes that wouldn't have a boiler, don't really have an opportunity to heat with high efficiency hot water. So there's an offering. It really has come from an A.O. Smith, American manufacturer. And it can outperform some of the bigger residential tanks. If people have jacuzzis, they need a 75-gallon water heater, which is a pretty big water heater. Now they can get by with this high efficiency. So this is an interesting emergence in the market.
What's the model?
This one?
Yes.
GSW.
GSW?
Yeah, if you Google GSW, EnviroSense is the name of that model. And there's a couple different ones. Go ahead. So then the other trend in terms of HVAC and air conditioning, we see this more and more that there's a demand from tenants to have comfortable living space. And a lot of times that will come down to air conditioning. You can ask yourself, when was the last time you got home from a busy day at work and went into a hot house? People don't really like overheating it. And I said this just last summer, either I'm getting older or it's getting hotter. But air conditioning is almost come to be a must for comfort of people. And your tenants, if you look at your tenants are like your customers. You want them to be happy, and you want to get good tenants. So we see this as a big emergence too. So cooling in rental units. And that's it. One more. Here's one of my technicians. Any questions on that? Kind of buzzed through it, made it a little brief thing. Yeah, go ahead.
Carbon monoxide, for how many, like what's the standard in terms of how many you need and?
Yeah, it depends on the piece of, oh yeah, sorry, I'll repeat that. So the number of carbon monoxide detectors required, it does depend on the piece of equipment. Now there's some clear legislation for residential boilers. You need a carbon monoxide detector outside of every bedroom and on the main floor, I believe. Now in apartment building, I don't think that's been flushed out in terms of with the new legislation. So I don't know the answer to that.
Okay.
But I would assume that probably one per unit. But I could be wrong. Lars?
But if you've got a boiler in a boiler room, why would you end up having carbon monoxide within the building itself? Because that boiler room is supposed to be self-ventilated, not can mix with the air of the building.
Yeah, I would agree. So again, I don't know. To be honest, I don't know. Say in a retrofit multi-residential, how they would treat that. They might have one in the outside hallway, but they might do it like smoke alarm. Right. A lot of times, so the carbon monoxide detectors are going to be enforced by the fire department. So they're going to treat it. It's going to be a sister to the smoke detectors. You have a question?
I don't know if you see this too often, but radiant heating in the ceiling.
Not that often.
Yeah.
Like
Is it efficient? Is it?
I would like it's in the only place I've seen are very old homes. I haven't seen it now. We've seen some wall radiant. I wouldn't think that is a big trend in ceiling.
Yeah.
Because the
built
heat-
in the 80s. This one place I was
Oh, is
looking
it?
at.
Yeah. I'm a lot of times they weren't using plastic tubes, so a lot of the radiant floor is in with plastic tubes, which are seamless. So any older building would be typically probably a copper pipe or a black iron fitted pipe. I'd be cautious about that. Any other questions? Yeah, go ahead.
You mentioned chimney vented boilers. However, you probably remember my building.
Yeah.
We don't have chimney, but we cannot have it vented outside by the balcony.
Yeah.
So if we put the liner inside, is it still okay?
It depends. It depends on the category of boiler. So you're asking about chimney vented
Liner for
boiler.
high efficiency.
If you went with a high efficiency, it would be it's a sealed vent, uses positive pressure, uses a fan to push it out. Then that would be okay. It's not the same kind of category as an atmospheric boiler where it has a draft to it. Air is getting sucked out. It's getting sucked out as opposed to being pushed. So high efficiency up the chimney is something positive. Go ahead.
Are there many direct vent, boilers or
Yeah.
like for like for rentals, or is that more residential?
Yeah, I would say every boiler manufacturer now has a direct vent model. So they would probably yesteryear they would have a atmospheric model up the chimney. Now everybody is going to a direct vent. Thank you.
Ladies and gentlemen, you may have some more questions for Stephen and Afterglow and George. I think they'll be sticking around tonight. So on the break, feel free to speak to any of the speakers tonight directly. And we're going to continue on with our program. Thanks very much, Stephen. Well done. And just to sum up Stephen's presentation, it's really important to have your heating and cooling systems working, and ventilation systems, as he said, working well. And it's a great way to attract tenants and get high rents with air conditioning, if you can add that, all the bells and whistles that you can to attract tenants. these days. So our next speaker is Josh Halbert from Keytech Water Management, and he's speaking on behalf of Canadian Water Cooling Inc. And they're here tonight to educate the members on a concept that many are not familiar with, but have been part of water treatment solutions worldwide for hundreds of years in some capacity. Parafos water treatment is the topic of tonight's presentation. Josh Halbert, representing the manufacturer of Parafos water treatment, will explain the many benefits in the treatment of commercial water and how it represents an alternative to standard water softening systems. If you have any questions, please save them until the end. Josh from Keytech has told me that they've been in business since 1981, and you can tell that tonight's theme is water, and his favorite color is black. So please welcome Josh to the podium.
Great sharing.
Thank you, everybody. Glad everybody made it here safely this evening. It was a treacherous road out there tonight. I live out in New Hamburg, so it was a bit of a dicey drive, but glad to be here tonight. As was said, Josh Halbert from Keytech Water Management. We're a local company that manufactures water treatment preparations for industrial and commercial and institutional boiler cooling, and as well once through corrosion and scale inhibitors such as our product Parafos that we're going to talk about tonight. I'm here on behalf of Canadian Water Conditioning. They were kind enough to invite me tonight. This is my first time to an event like this, and appreciate it. Canadian Water Conditioning is our local principal dealer of Parafos, so they're well knowledgeable and have been in the business for a long time as well. And with this product, they have a very well-rounded approach now, so I'll explain. The first step is to discuss the medium, water. Water is essential, it's life. Essential to life on Earth, as everybody knows. 71% of the Earth's surface is water covered. However, 96.5% of that water is saline ocean water, so not readily usable for giving life. Only 1.7% is present for groundwater, so deep wells and aquifers, things of this nature. And 1.7% of it is frozen in the ice caps and in glaciers. As people are discussing now in the scientific community, that's becoming, that percentage is dwindling as we speak. So, and 0.001% is active precipitation that is constantly driven through the hydrologic cycle. So that only leaves 2.5% on the planet available readily as fresh water. We in Canada are lucky to be around an estimated 20% of the world's freshwater supply. This is an estimate, but pretty abundant in our country. However, despite the abundance, it's highly overused in Canada. Industrial processes, population concentration, as we know. Water is stressed, overused, and we need to respect it. Just like others in the world, we don't have quite such a supply as we do. Now, water quality is of utmost importance to understand. We're blessed to be, again, with an abundance of water in the Waterloo region. Speaking of the region, and the good people from the region, Wayne and some other fellows are here, so I'll be kind. But they serve as the wholesaler of water for the region, so all the cities and the townships. And basically, they do a very good job of taking our groundwater, as well water, a small percentage from the ground, and making it palatable, safe, and good looking, and good smell. Various processes are applied depending on the local water quality, and basically at the end of the day, they're delivering a quality product that's safe and ready to use. Luckily for us in the water treatment industry, however, it's quite a tough medium still because of dissolved solids. Dissolved solids are quite abundant in our water here due to the deep well system, and they pose a significant challenge for residents, for homeowners, businesses, and industry, as it is quite hard. Calcium and magnesium laden represents total hardness, so total dissolved solids. Dissolved gases, primarily oxygen, also are troublesome in that they induce corrosion. So anything from your copper piping systems, heat exchangers in your boilers, and mixed metal systems are susceptible to these maladies. So, what's the point of all this? We're talking about water, the quality. Why does it matter in building management, you might ask? Well, in our opinion, the cost performance is important to the owners, to yourselves. Basically, you're looking at running a business, and having an inefficient system, an inefficient building, is not cost effective. As well, it's a protection of your investment. Buildings can have from anywhere from $10,000 to $50,000 up to $1 million worth of boilers, piping infrastructure, fixtures, depending on the units and size. We also are concerned about delivering quality water to the tenants. The tenants aren't going to want to have water that has a malodorous or appears off or is causing them problems. So that's a concern. And as well, we want to foster community leadership by conserving our resources. You know, water is certainly not free, and it's not something that we can just pass through and then waste as much as we want. We don't want leaky taps, we don't want leaking boilers, and we want to protect our resources. So four key points we're actually looking at when we're considering building management is, again, fixed water costs. This is something we can't control. The region sets those prices for us, and we willingly pay them. So this is one thing we consider. As well, again, the infrastructure, very important throughout the building, and new capital equipment. We certainly don't want our heat exchangers and boilers and things like that to be expiring before their due date. I know that good people at Afterglow might be happy with that, perhaps, but at the end of the day, we want to get our life out of our equipment. As well, operational costs. Having a high efficiency unit that is full of scale and calcium and so on, that renders it low efficiency now. We're not doing it in for our pocketbook. So these are our chief concerns. So I'll speak a little bit about water treatment standards that you might see in building management. Water softening, the old standby in the region. For those of you who aren't familiar, just a show of hands for owners and managers, who has a water softener or is utilizing one in the facilities? But a good percentage of you. Okay. Just to Cole's notes on the process. Basically, we have this calcium magnesium laden water that comes into our building, and water softener provides an ion exchange process to trade calcium and magnesium ions for sodium. So you're filling up that salt tank and you're wondering where it's all going. There's a media inside of the water softener that is charged with that sodium, and it willingly exchanges it for the calcium and magnesium. This provides select systems or entire facility with soft water. So you can choose to simply soften the hot water or hot and cold or whatever you choose. It just depends on how the piping and the layout of the building is. Water softening, let's go there for a second. Water softening now they're coming up with better and better ways to make water softeners more efficient, but it can be cost prohibitive, especially with a large unit, triplex, like a three-phase system. As salt is ever increasing in cost, regeneration water is at a premium, and it is also labor and capital intensive. We have to maintain the water softeners. We have to pay people to load the salt tanks. We have to make sure that they run smoothly. So these are all things to consider. Other types of units we see are methods of filtration. So if you happen to have a facility that perhaps is in a rural area, again, we don't see too much need for this in the region, other than if you desire to take out chloramines or chlorines out of the city water, which is sanitation chemistry they use to keep the water safe for us. So using activated carbon and things like that. But as well, we can utilize either cartridge filters or standalone large systems like this for iron, debris, sediment filtration, things like that. I'll speak a little bit about alternative approaches, and I call it the unusual suspects. We see sometimes in the industry quackery or a little bit of pseudoscience happening, things that aren't quite proven out. This is one example, magnet therapy, as I like to call it. The suspect method of supposedly aligning the hardness ions in a pipe such as a way to inhibit crystallization. Studies show that this is not a proven science. It is not recommended. We have a deep and vast body of experts and scientists, peer-reviewed studies that show that really all that you're going to do is perhaps collect a little bit of iron near the pipe wall, and that's about it. If these sort of systems really did work as the slick salesman would say, I'm sure Culligan and the quite large water treatment companies in the world would adapt their own version, brand it, and sell millions of them. But the fact of the matter is that they don't, because they simply don't work. No offense to anybody who might have one or believes in this, but it just really doesn't flesh out very well. There's another emerging trend, very, very shady sort of approach, very slick salesmanship. I hid the manufacturer's name for legal reasons here on this picture. Or they say it's the green choice, saves water, saves electricity, eco-friendly. Electropulse softening. So these good people believe that if you strap a copper electrode around a copper pipe and give it a little bit of amperage, that for some reason it's going to create a sonic pulse in the pipe, and it's going to tell the calcium magnesium not to stick through a heat exchanger or build up in a water heater, which of course really is not very logical. So again, something to stay away from as well. So the crux of what I want to speak about today is phosphate water treatment, or as we've branded and patented our name, Parafos. A little bit about the history and the use of phosphate treatment. Polyphosphate has been used for corrosion and scale control in municipal, commercial, industrial, and private facilities for decades. It's been part of boiler treatment and different industrial processes for over 100 years. Parafos has been, our product has been marketed and used in facilities for all of our 33 years. It was our primary chief first product we put out in the market. And in fact, Regional Chair Ken Sealing, when he was the mayor of Woolwich Township, he wrote a record, he cited in the record in 1983 as utilizing it and approving it for use in Elmira at arenas and different facilities there. So it has a long history locally, and it's a product that we export all over North America. Monophosphates in scale control for steam boilers, as I mentioned, and the newer technologies, synergistic phosphates that work together to perform different functions, are now being used and blended, such as Parafos, for high performance applications. Some examples of large-scale phosphate programs, specifically for corrosion control, include the City of Toronto, the City of Sudbury, City of London, and City of Winnipeg. So some quite large municipalities in the city centers that utilize this sort of technology throughout the entire infrastructure. These people are mainly concerned about lead leaching and lead corrosion in the city infrastructure, but it works well nonetheless. Polyphosphate treatment. So we understand now that it can provide a short return on investment solution for your facility. Significant water savings is the primary reason why it's such a good treatment to use. It, in fact, can replace water softeners one-to-one in that, and I'll explain later, the technology is rather than replacing the calcium magnesium, it ties it up and keeps it flowing in the system without the use of copious amounts of salt and regeneration water. Examples of water and wastewater salt combined cost reductions have been seen in the tens of thousands of dollars in some large units locally. So this is real math that's been hashed out. And additional savings and rebates may be available through the Region of Waterloo Water Efficient Technology Program, and Wayne could possibly touch on that a little bit later. So there are some incentives to show water savings in facilities locally. The region is interested in this primarily because it's a green thing to do. It's economical to do for the region. It helps us all as taxpayers, and really to abate the eventual need of a pipeline to one of the Great Lakes, I understand is one of the big reasons why we want to save water and put that project down the line. So again, focusing on Parafos is indeed a food grade scale and corrosion control chemistry, and again is formulated locally by us at Keytech Water Management, and Canadian Water Conditioning is the principal local dealer. And this product is also certified to many bodies, Canadian Food Inspection Agency. We're allowed to use it in industrial heating systems for food contact use, because it in and of itself can actually be found in the food they're manufacturing. So there really isn't an issue with utilizing it through heat exchangers and boilers in industrial settings. We also have it certified in the US and throughout North America to NSF Standards 60, which is an approved and audited drinking water formulation. So it certainly is regulated and rigorously safety. So system operation and benefits of use. A Parafos system is very, very simple in approach. Basically, after the water main and your backflow in your building, you would simply install a water meter and a proportional dosing pump, as seen here. We put together tidy packages where you have everything mounted on a board and very easy to utilize. The Parafos is then set by our technicians to an appropriate dose rate, up to 10 parts per million, which is the maximum allowed usage. And basically, as the water flows through your facility, it's metered directly in proportion to the water flow. So if you have peak demand in your building when everybody's having a shower, it keeps up very nicely. And when nobody's using any water, it's dormant. So it's a very precision way to accurately dose the treatment into the system. Again, one of the main benefits of utilizing this sort of chemistry in a building is that corrosion control is primary. Phosphates are well known molecular filming agents. It's not that it would physically coat or film or add something to the naked eye, to the pipe wall, but rather it's a molecular film. It's something that is not seen, but in fact what it does is it inhibits dissolved oxygen from starting a corrosion cell. So what you'll see here on the bottom picture here are very aggressive oxygen corrosion pits, and this is what will lead to what is typically called pinhole leaking in pipes. So again, Parafos is very good at preventing and extending the life of copper systems as well as mixed metal. So if you have systems where you have brass, mild steel and you might have galvanic coupling where you've got corrosion that way. It also protects from these things as well. And then acting as a sort of a water softener in a sense, scale control is the main benefit in the Waterloo region, of course. And again, I explained earlier, Parafos doesn't remove the calcium magnesium, so it is present at the tap. What it does is it actually molecularly ties up the calcium magnesium, so it doesn't have the ability to form crystal structures, scales, even at very high temperatures. So it allows it to pass through your system, inhibiting this sort of nasty accumulation in your pipes. These are actual pipes that we've cut out of sections, and just to see how little flow you're actually going to get over these 2 or 3 inch pipes. Also very important to note that heat exchangers, high efficiency systems nowadays greatly benefit from having a minimal scale buildup to continue to be high efficiency. Another added benefit, just due to the nature of phosphate, is that it provides staining control. Now, this isn't something that we really have a major issue with within the city, in that the region does a great job of removing dissolved iron and things like this. But it's worthy of note that Parafos also ties up dissolved oxygen molecules, and so it inhibits oxidization of iron. So when iron is in solution of the water, it requires an oxidizing agent to, primarily oxygen, to kick it out of solution, and that's where it can cause a staining effect. So by tying up these gases, the staining will be alleviated. So it's a nice byproduct of utilizing phosphate. And that's all. Thank you very much.
So you're going to take questions?
Yes,
Okay.
go ahead.
Just for the injection, does it require like a tank, or is it a direct line injection to it? So it's paced at that 10 ppm and it's a small enough injection rate that it's able to inject at the small rates?
Typically what we'll see, and again, we basically size up the application. So if it's a small duplex or triplex, certainly we'll deliver it actually straight out of one of our delivery pails in a liquid solution. And again, we'll size the pump appropriate so that depending on your flow rate and your concentration of product, we'll deliver it appropriately so as you don't overdose or underdose. So, sizing the system, we have units in town where you've got 300, apartments that we have 300 units. You're using 20,000 gallons a day, several hundred cubic meters. So we'll use larger vessels, larger pumps, and size it appropriately.
So you have like a mixing tank where the incoming water mixes with it, or is it, say, a 2-inch or 1-inch line where you're directing into that, or is there a large vessel where it's mixing with it?
So we inject basically in line, and we want to do it so that it's not cross flow. We want to inject it, so we'll actually take, like if you have a 90-degree elbow, we'll actually make it a T and get it mixing in a line, give it at least 10 feet of mixing before it actually travels anywhere important. Yeah, and it's fed neat from the container, so we don't need to make a slurry or anything on site. It's delivered right from the canister.
What kind of pump is it that injects it?
It's a diaphragm dosing pump. We primarily deal prominent equipment. They're German made. They're distributed out of Gulf.
Okay, yeah. So the diaphragm pump, which injects small pulses at a time, and if you're suggesting that if you have a long enough length of pipe, that there's back mixing within. That's not like a plug flow reactor where there is no mixing. You're assuming mixing within that pipe then.
Right.
Okay.
And if the length of pipe isn't sufficient enough, we can actually install a static mixer. A section of pipe with,
like a helical mixer or something like that.
Right.
Okay, yeah.
That's right.
And so is that done at the time then you determine if a helical mixer is required?
That's correct. basically a site survey would be conducted, and all these matters would be considered before installation.
And sorry, would you have a typical cost per unit volume that would be typical here? Like if you're injecting 10 ppm, what would the solution cost? So if you could, do you have any idea on what it'd be so many dollars per cubic meter of water?
We could, I suppose we could chat about those things after the seminar. Yeah, there are very basic pricing schedules for this. Yeah, it's very simple. So, any other questions? Yes. Yeah.
Yeah, what is the percentage of build-up removal in scale control? Is it 100%, 90%, or, you mentioned minimizing scale build-up, but is it complete scale build-up removal or partial?
Are you talking about, like, it does have the ability, in fact, to remove, are you talking about removing existing or preventing new scale? It's very hard to determine. Even with water softeners, other minerals will eventually build up. So when you're dealing with calcium and magnesium, I can say that it's complete, it's 100%. But again, other factors have to be in play as well too. If you let the pump, or let's say you let the container go dry even for a week or so, now you're having a percentage of hard water go through that's untreated. It's the same as if you had a water softener in place, you didn't fill the salt tank. So our product is able to perform at 100% efficiency while it's in operation. But I don't think there'd be any facility that, it would be 100% of the time. There are hiccups and margins of error, but it is a very, very highly effective product. I would say if you had to estimate, in the high 90 percentile, if you factored in some human error or things like that.
Yes, and how does it help corrosion control in existing pipes which are already corroded? What's going to happen when you install the system in the old building?
It's not going to aggravate any existing corrosion cells. It certainly can't heal any existing pits in copper or mild steel or anything like that. It's certainly not in other chemistry technologies you can actually heal passivate steel and copper. This technology doesn't have the ability to do that, nor would you want it to in a system where it's potable water. So really what it would do is just inhibit further corrosion, really is what you would be able to promise out of the product.
So it would be advisable to install it in older buildings, right?
Absolutely. Older, newer, many benefits. I can answer more after that. Yeah.
Thanks, Josh.
Okay, thank you very much.
Well done.
Thanks, that was Josh Halbert from P-Tech Water Management. So we're going to be having a break right now.
Sorry about that, folks.
Okay, so my name is Rachel Duran. I'm the Residential Water Efficiency Coordinator at the Region of Waterloo. Some of the background on the region. We supply the drinking water to the whole region. 20% of that water comes from the Grand River, 80% comes from wells. Now it fluctuates depending on the season, but that's the average. We operate under a two-tier system here for the 3 cities and 2 of the townships. On the 2 other townships, the 2 being Wellesley and North Dumfries, with 1 tier, we operate that system completely. So we are actually a wholesaler of water. We sell it to the cities sell it to you, but we treat the water before it goes anywhere and even as much as add the fluoride to the water for water. Water efficiency is a section within the Water Services Department, which is part of the Transportation and Environmental Services Division at the Region of Waterloo. Part of our long-term water strategy states that it's cheaper to use currently available resources than to drill more wells, build more plants, or build a pipeline to Lake Erie. And Lake Erie is where we would have to build if we were to build. So that's one reason why water efficiency is very important here. The population growing, but we want to continue to kind of stay with what we have in the way of water. So the big thing with, I think probably a number of you may have taken advantage of this already, the toilet replacement program. It is being discontinued as of June 30th of this year. So that's the last day that you can purchase a toilet. Then you have 6 months to put the rebate in. You can purchase the toilet and install it after, but the receipt date has to stay June 30th or before. Now, it has been a 20-year program. People say, why are you stopping? Well, we've rebated almost 80,000 toilets in total, and 27,000 of those have been in the multi-res sector alone. 20 years ago, toilets weren't necessarily that great. Even the 6 liters, there were some issues with them. But you try to get people to move that way. But toilets now they're very good ever since we have done independent testing. Now, a few of the reasons we're doing that, of course, is because of just the 19 years. But also the Ontario Building Code. It's a 2012 building code, but it came out in January 2014 is when it became effective. And underneath that code, not only all new construction, but all new construction and renovations have to put in HUT toilets, which are 4.8 liters or less or do a flush. So the mandate is already there from the Ontario Building Code that that's what you need to put in if you're putting in a new toilet. But there's still, we still want to promote the water sense because there still are even some HUT toilets that may not work so well as with any fixture you get. So we still want to promote the water sense, but it's not worth giving a rebate on anymore. So the region is in the middle of the water efficiency master plan. It's due to hopefully be approved in June of this year to take effect January of next year. And part of that is a proposed flapper replacement program. Flappers are one of the most common causes of toilet leaks in a toilet. There are other things like the overflow, but flapper is the most common. They really do need to be switched out about every 3 to 5 years, and that's not the case. Most people don't do it, and especially when I do inspections in multi-res, I get frustrated with tenants, not the landlords, the tenants, on the leaks that I see in the bathrooms, and flappers being one of them. When I go in, the tenant will say, oh, I heard that running for months. But of course, they don't say anything to the landlord. So having a flapper replacement program, we do things like online tutorials, print material, rebates or giveaways. But for the landlord sector, rebates or giveaways would be the best. That'd be hard to do with single family. But we could go into a 20-unit apartment building and say the toilets were replaced. We could look at our program data in 2000, and you haven't changed your flapper. You should probably change it. We could help you purchase them because we know the make and model that was put in. It's all in our database. So it's a perfect fit with the multi-residential. Now, we don't know, we're pretty sure we're going to go ahead with it. It's proposed, and if it's approved, we will move ahead. We don't know the exact makeup of it, though.
Are they free?
Are they free? Well, that's what I mean. We don't know the exact makeup, whether it would be on a cost share or whether we supply the flapper and, for you to put it in. But that's all. Because it's not going to be approved until June, you do some preliminary research, but you don't, from June to December is when we really be putting in the program particulars and exactly how we're going to administer it. During that time is when we'll know for sure how we will, whether it's cost share or whatever. And then also for multi-res, the Water Efficiency Technology Program, the WET program, is also something that landlords can look into, and Wayne will speak to that when I'm done. Now, flapper replacement case study. This is an excellent case study. Consumption, this was of a retirement a long-term facility in the Kitchener of Waterloo. Their water consumption was going up and up. In the years of 2004 to 2009, it averaged 19,100 cubic meters. 2010 went to 27.7, 2011, 38.5, 2012, 48.6. They knew there was a problem, but they were building a building right beside, and they thought, they weren't sure if the problem maybe had to do with that building being built, or whatever. But anyway, they got city Kitchener consumption data and were able to identify the problem through that. They also, and they also looked at, I don't remember how many, but other similar properties in southern Ontario and saw that their water consumption was exceptionally high. So they figured, they looked at it, toilet run-ons was the problem. So at the end of 2012, they replaced out 161 flappers. Now it was by in-house staff, so there wasn't a plumber cost, but so it was just the cost of the flappers. $300 is what it cost them for 161 flappers. Over that course of 3 years, they lost $175,000 in wasted water just due to flapper. So that's where we really feel the flapper replacement program, or especially in multi-res, is an ideal way to go. It helps you as a landlord, it helps us as the region. And I think that's about it. I shall pass it over to Wayne.
Thanks very much, Ruth. So let's tweet that out. Our last speaker tonight is Wayne Brabazon. Thanks, Wayne, for being so patient. Wayne is with the Region of Waterloo. He's a water efficiency technologist, and he's been tech for 16 years, and his favorite color is blue also.
Thank you, Bill. I'd just like to say Bill's going for a job at the region where you put a flapper in your crapper. Communications and water efficiency. And the lady over there, back there in the red, I'll talk to my wife. She's red canned. So I'll get right on the your HST thing. But I don't think too much will change there. So what I do all the commercial, industrial and institutional side of water efficiency. Ruth is the residential side. So what I do is give money away, and I give it away in two primary ways. In a large business, so commercial, industrial, institutional is doing a water audit. I'll split the cost of that engineering audit, and if they're doing a specific project, I'll split the cost of engineering, basically engineering consulting. So that's big companies. But when there are something is implemented and there's water savings, we pay out a rebate. It's a capacity buyback rebate at 40 cents a litre. And so there's money there. And that's the two ways I can give money out to make water efficiency happen. I do free water use reviews, but that tends to be the smaller businesses like church size and that sort of thing. Once you get into a big plant, or they'll often have a consulting firm involved. Toilet replacement program, that touched on commercial side, that's ending as Ruth talked about. I do still rebate $150 for flush valve toilets. That's your kind of your chrome commercial kind of toilet we'll see in office towers. And I also assist with sort of water efficient bathroom and kitchen aerators and shower heads, and I give some of those away. I mean, with the landlords, some of your townhouse complexes, I can't give away enough to do a whole townhouse complex, but I can give, sort of like 10s, 20s, and as samples, that sort of thing. In the water efficiency world, we sort of, there's standard equipment, and benchmarking. So aerators are down to a gallon per minute, kitchen aerators 1.5 gallons per minute, shower heads 1.5 gallons per minute. Now I am leaders, so 4, 6 and 6. The ultra low, there are ultra low flush toilets, 3 litres per flush. Now a large seniors company in North America that does seniors homes, the 3 litre they like to be 3 stories or above. If there's a 2-story or below building, they don't they'd shy away from it. But 4.8 litres per flush is just sort of your high efficiency toilets. Your dual flush are 4 and 6 litre, and flush valve toilets 6 litres per flush. So these are the sort of standards of water efficient equipment. And if you have a lot of units, it can't hurt to switch out all the aerators and shower heads. I'm sure you could buy, sort of some bulk amounts and switch them out. It helps your tenants, and if you're paying the water bill, it certainly helps you. I'll give it, anyone that wants a copy of this presentation, I'll have them at the back there, and it has our contact information, and it has this link in there to our conservation webpage. And the sort of companies I deal with tend to be large companies. Your Brick Brewing, Toyota and Suds Express, they did water reuse projects, big projects. Marsland Centre and Brick Brewing, they changed some of their equipment on cooling towers and pasteurisers. And again, these people are all getting rebate money for large volumes of water saved. Rim Park and Chicopee Tube, they do rainwater harvesting. Babcock and Wilcox, actually most of their water was domestic, switching out toilets. And again, all these companies got some money. Canadian General Tower changed a lot of their water treatment equipment because they treat their water before they're processed. They plastics manufacturers. Now, on to you guys and as landlords. Townhouses and apartment buildings tends to be obviously domestic water usage, so it's aerators, shower heads, toilets is where you can attack your water use. Leak detection is another thing. I can flow log, if you have a problem. Typically, how that's shown up on the radar is there'll be like townhouses where there's the same number of units, and there'll be 70 units or so, and they use like 16,000 cubes on average, and then one place was 24,000. So they had a problem. It was way above like-minded. Ruth mentioned those seniors' houses where they were comparing 6 or 7 other properties, and this one that she mentioned stood out, and that's benchmarking. And if it does use way more water than like-minded properties, then flow logging can tell you that maybe water's flowing in the middle of the night when it shouldn't be. So that's what I see mainly in your sort of properties, multi-residence properties. Another project we paid out on was the High Point property, a large apartment building down near Fairview Mall. And this is the Parafos product, and Josh was talking about. And basically what they're doing there is obsoleting water softeners and coming up with the alternative treatment, which Josh described. Now, the chemistry of that treatment is good. It's a sequestering agent, and basically it's tying up the calcium and magnesium in a complex molecule. I have a chemistry background, the chemistry makes sense. We had a study done as far as food inspection and NSF, and it was good, and it was a good water saving project. Water softeners use a lot of water to regenerate. How many people here actually run water softeners in their property? I think, and so we have my wife and I have a rental property, and we don't, and so it's a judgment call in rental properties whether you're going to run water softeners or not. The tenants will fill up the salt, or whether you do. But the Parafos product in the large properties is an option you can consider. I'll just pass on. I mean, you guys are landlords, but this is just some generic information on what I've learned in Water Efficiency 101, and it applies equally to your own house, as to your rental properties, as to your businesses. Firstly, water is continuing to go up. It's like more than doubled in the last 10 years or so, and it certainly is catching up with hydro and natural gas. I know that from the numbers in our house. It's going to continue to go up because a lot of the money that the region's spending is on wastewater management treatment plants, and it's only going to go one way. The other thing is it's always prudent to monitor your utility bills. Month over month, I had a problem at our house this summer. It turned out it was a water softener, venturi valve needed cleaning, and a running toilet. And where we're 29 cubes every month or so, it became 45. And identified the problem and fixed it and went back to normal, and a couple $100 and lost water just in a residential setting for 3 months. But you should be looking at utility bills. If you guys are in some big companies where the finance department has a utility bill, that's not great. They pay the bill, I get that. you need to be, if you're managing your properties, looking at the consumption. You know, keeping some records, using a spreadsheet. You know, really in this day and age, it's not hard to put things in a spreadsheet and just track it. And one thing I will mention, you always want to be monitoring the consumption, not the dollars. The dollars, we control the dollars of the region. We tell you what the rate is, but you control the consumption in your properties. Or a response can have some influence on that consumption, be it efficient equipment. I love sub-metering. Sub-metering now, sub-metering plants is a good way to go to sub out where the water's being used in the plants. In the Babcock and Wilcox example, it turned out most of the water was domestic. They had 800 staff, 500 engineers, 300 welders, and a bunch of processors testing their big nuclear waste tanks. But most of the water was domestic, and they wouldn't have known that without sub-metering. Now, sub-metering for landlords is a different meaning. I'm a believer personally, and this is me being my drum, in separate meters for water, natural gas and hydro. In Ontario, we tend to say sub-metering when we're talking generically hydro, but there's 3 meters in your properties. I believe in sub-metering, both in commercial settings and landlord settings, because you know, then you get a much more responsible tenant if everything's sub-metered. I'm not quite sure why you'd want to pay your tenants utilities personally. That's my slice on that. And it's a water efficiency thing. If people are paying for their own utilities, they're going to be more efficient. So from a water efficiency technologist point of view, that's why I believe in it. Benchmarking is not a bad way to go. If you've got similar properties, you know, if you've got a fourplex here and a fourplex there, and one fourplex used 4 times the other fourplex, and there's just a bunch of different people in there, then that could raise some red flags too. Benchmarking is just comparing. And leak detection, like I say, I have done some work at some townhouses where we just flow logged and they could see water was flowing all night. Now then it comes up to them to get a plumber in or figure out where the water's going, but it's a case of why is this water flowing all night? So there's some of the things I've learned in water efficiency that I think are important. Fit that bill. So basically that's, I've tried to make it somewhat relevant to landlords. That's my contact information. So I just want to fit it one more time. So if you have any questions that you would like to address. Yes, I think the lady down the back.
Do you deal with water efficiency like on the city's infrastructure, like the under the ground
yes.
water pipes? Like how are
yes,
there
yes.
leaks throughout the city?
That's a good question. Excuse me. I actually am responsible for 2 areas, 2 line items in our budget. And one of them is CII, exactly what I described, everything non-residential, so commercial, institutional, industrial. That's one of my line items. The other line item is what we call leak detection, but it's leak detection in city and municipal infrastructure. So what I do is promote a thing called DMAs, District Managed Area Protocols, where I have a number of consulting companies and I try and get the cities and townships on the side, and Woolwich has been very proactive, and Kitchener, and Cambridge to a degree, and what we do, these engineers go in and they break, like air for example is 2 DMAs, and in Kitchener there can be many, and they've done a few, and they break an area out and they have some operations guys go out with them overnight and they turn off valves and they flow log and they have software, and it's very sophisticated, but what they're doing ultimately is looking at what they call minimum night flow, and so they're doing it in the middle of the night when everything's quiet and there isn't a lot of water use, and they're doing a theoretical water use and actual, and the difference is what they're going after as far as leaks. You know, they then go and they look for some leaks.
$100 and some odd dollars.
We're going to do membership draw. How much is the draw for, St. Mike?
$90.
$90. Remember, you have to be here to win. If you don't win, if the person's not here, then it's going to be $100 in May for the May meeting. Okay, and Oh, I know this person. Unfortunately, they're not here. Dave Chatterton from Great Northern Insulation. If Dave was here, he would have won $90. Thanks very much, everybody, for making it out today. Please share this information with your landlord friends, with other people in the community. We can save water, save energy, save money, more money in your pocket. So the meeting's adjourned. Excellent meeting. Have a safe drive home.